Alright, another draft physics video presentation. I'm talking to Zohar again, who's kind of a believer, but I don't know if he understands it well enough to be an advocate yet. But anyway, so he does still have questions. So figure other people likewise have the same questions. So I'll try to answer the questions as thoroughly as possible, and we'll see if there's any through the conversation, any value to be gleaned and such and so forth and whatnot. So anyway, hey Zohar.
Hey,
So what's on your mind?
all right, I guess I could just start. Like, I feel like I pretty much understand gravity and magnetism and even like time dilation pretty well. Like, I kind of know where each kind of force bit has to go and all that to cause these effects and stuff. But I'm still like a bit confused about the kind of single slit and double slit experiments. So maybe we could just talk about those for a bit.
Sure. The thing with the double slit is that I was thinking about it tonight. I mean, there's just a guy made a simulation. I'll show that sometime. And he just has balls bouncing off things, and they're changing speeds, and they're doing different things, and it looks interesting. But I mean, I've sort of made it clear that photons only move one speed. The real thing the slit experiment is made out of is just phase. Then the math is sort of rigid. You can't really change. There's no way to misinterpret the experiment in a sense, because it's just two lines that add up to either being in phase or out of phase. So they're either, I guess I could draw it. We'll attempt anyway, see how it goes. How much of it you can see. Yeah, that blackboard, you can see that. Yeah. All right, so it's really just lines that have a length, and the length is basically just going to be broken down into where the little clumps are. And you're just saying there's two places that are sending a line, and the line has a certain length, and the length is basically going to say where is the clump, right? The clump starts here and it starts here, and it's equally spaced. And the point is where the clumps add up, like that, where they match, is where you have them in phase, and that means you're going to have a photon. So, their math is my math. It's the same, diagram. Oh, that video needs to be fixed. Yeah, this drawing.
Oh, did I ruin it? Or
Whoops.
I'm just trying to get closer to the whiteboard so that it's easier to see.
Yeah, well, I just have to fix what I have on the video screen too. I want this to be visible, and I don't really have it in the right place yet. So I have to move this one. Okay, move this one over. There you go. All right. So anyway, so all there is there's just two slits, right? Okay, and there's just this simple math that just says there's
Wait,
lines.
can we start with just doing the single slit first? I feel like it's probably easier.
Yeah, well, it's really it tells you the story, and so what a wave would do, water wave would just create a clump. So that's not going to get you anywhere. That's not going to create interference. So obviously it's nothing like water, and the light really is going to make two point sources at these surfaces. And what you're really saying is there's going to be lines that come off of these 2 points, an infinite number of little possible directions that the little bits can travel from those 2 points. And so those could be looked at as waves. I mean, you could draw them as waves, but obviously it'd be kind of weird because they're going over the surface. But anyway, the point is these are your vectors to a point in space. So if you draw this equidistant idea, you can sort of understand that there's points where when the lines converge from these 2 points, they're one whole wavelength, one whole notch, okay, out of alignment. So this one has 2 notches, this one has 3 notches, but their notches match when they get to that point.
Wait, so are you saying that they reach the point at the same time? Like,
yes,
exactly.
Like well, it wouldn't be the same time, because obviously a photon is a timed event. So there's where you really want it to be. You just want it to be in the right locations in time. So this one could arrive early, okay, and travel the longer. Like this one could arrive first, but it's traveling a longer distance, so it gets here. and this one arrives 2 seconds later. The point is at the phase. All that really matters is from the point they left, this location and this location, are they in phase? Okay, now it could still be a notch behind, okay, to create a photon. But the point is that the phase lines up, that the little notches on their rulers match. Even though this one only has 2 and this one has 3, when they get here, it's going to be a matching notch. They're going to be in phase.
I mean, but in phase, do you mean that like one of them goes kind of here, the other one goes here, but when they actually get to this point,
well, like I said, obviously a photon, I'm saying, is a timed event. So obviously they can't get there all at the same time, and it wouldn't be a photon. That would be this, you know. I mean, if they all got there at the same time, that would just, well, can't see that. Yeah. Okay, that would be a clump down. Well, you can see it.
That would make the frequency much lower, right? Because then.
Well, yeah, you're breaking the frequency. The whole point of phase is to restore the frequency. So let me just come up with a way of drawing it. Look, it's just, look, this is phase. Now, if I sent another pieces, so this is this line. This line has this stuff coming at it. And the point is, well, it really doesn't. You know, it just has one contributor, and the other one's going to fill in that blank. But the point is you understand out of phase. Out of phase would be combining these two, right? And then you would have a higher frequency, so that they're not in phase. Wow, that's really off again. Camera keeps not cooperating. So out of phase is no good. You can't make a photon when they're out of phase. So the point is you're just taking pieces from the 2 locations, and you're saying, well, this one arrives here, and it hits. And then a little bit later, this one arrives. And then another clump from over here arrives. And another clump from over here arrives. And they arrive at the right time. They're all in phase. They're all at the same distance from each other. And then you remade a photon. If they show up at a different time, you know, like this, well, that can't be received as a photon. It's the wrong pattern. So it has to be in the right timed pattern. So you're just basically taking photons that go in that are in order in a right time. You're sending them to different directions, different places, and you're just putting them back together again. You know, you're just reconstructing what you broke by going through the slits.
So I get like how the middle photon would just go, or like the middle photons would just kind of get to the other side, and there wouldn't be.
Well, they're not going to hit anything, right? So they're not even part of the story. They're only 1 millimeter here where the slits are. They go up here and they only fill 1 millimeter on the board. So 90% of the photons don't go anywhere. They don't spread. They don't go anywhere. They go straight over here and hit.
Okay, I guess it's good to know that it's 90%. But I guess my question would be, like, when they're scattering, like let's say there's an electron, so there's just an electron that gets to this surface here. Is it going to scatter, like, is there kind of a probability of where it's going to kind of scatter? Like,
no, that's the whole point of scatter. The whole point of scatter is that there's no probabilities. It's scatter, so it can be any one of a million or trillion directions. So the idea is the electrons are just sitting there, the photon, a piece of it. See, the photon isn't going in a straight line, so the electrons are in different locations, and different pieces of the photon are going to hit different electrons. Some will hit none, some will hit 5 electrons, some will hit 10 electrons. So they're traveling, okay, 90% of the photons go straight through, because they're not going through electrons. The only ones on the surface of the material is where there's a lot of electrons. So those are the photons that are traveling this obstacle course. And yeah, they get bounced this way, they get bounced that way, they hit this way, bounce that way, they could go this way, they could go that way, they can hit this other surface and bounce off that. They're just getting randomly scattered in all kinds of different directions. Okay, so they're like basically, so they leave these 2 openings, the surfaces here. You could argue that some of them leave going this way from a lower point. Some of them leave right from the very edge. Some leave from different places. But basically the point is you have vectors from these 2 surfaces going in both of these directions. So you just have basically an infinite choice here and an infinite choice here. You know, a lot of choice.
Yeah, I feel like then it should be easy to do this in a simulation. Then, like, just have the force bits go here, and then once they get um, to the surface, just send them in any random direction, basically.
Right, and all you're doing is reconstructing the ones that are the right length. Okay, any lines that equal the right wavelength distances will end up being photons, and the ones that don't. And so you can just figure that out on this curve. You can just figure out there's places where you can make two lines that will be in phase, and there's places where the two lines won't be in phase, and so those will be your dark spots. So your light spots and your dark spots are completely dictated by the distance of the slit opening, and the distance of the slit opening is really, you're just dividing it by the wavelength. How many wavelengths fit in this distance, and you're just going to put those same number of wavelengths on this 90-degree arc. This 90-degree arc is going to be a perfect mirror of how many wavelengths are here, because that's basically telling you how many times you're going to be on phase and how many times you're going to be off phase. The number of wavelengths tells you the answer, and you just display it on that arc. You're done. The pattern.
Right, I guess, like, I just kind of don't see why the pattern arises from a random distribution. Like, I feel like it would be a random pattern or something, or like maybe it would be just even light everywhere if it was completely random.
Well, again, it's just because of the odds. I mean, it doesn't. If I took two frequencies, you could understand that if I took two frequencies and just ran them, you could say, well, they're this much off, and I could make them a little bit more off, and a little bit more off, and a little bit more off until I'm halfway, right? Until I have them in between here. And so that would be 100% out of phase, right? You get that part, right?
Yeah.
So everything in between there, though, could be light, okay? Could be good enough. And so that would be remaking the photon because it's close enough. And if you look at the pattern, the light bars are bigger than the dark bars. Light bar, dark, the darks are much smaller than the light sections because you can be a little bit off. But the point is that it's all just vectors. I mean, I can't. If I drew it with string, so I just took a piece of string and I tied it to the two surfaces, and then I put a nail here, and I just moved the string on this arc, right? So the string can't get any longer. All I have to do is put notches on the string, and as I move the string over, this notch will be here, then this notch will be here, then this notch will be here. As I move the string, you'll see the notch keeps moving, and that's the same thing as saying where are they in phase. So where you line up on the notches on the string is where you'll have them in phase, in phase, in phase. So they're hitting randomly everywhere, but just by random, you're going to have places where the length of the lines is right. Where this is a full wavelength longer than this line, you're going to have light. Full wavelength longer, you're going to have light. Full wavelength longer, you're going to have light.
Okay, I think that just explained it pretty well.
Okay. So the scatter, it's just you're inevitably going to put the photons back together whether you like it or not. You don't have to do any work. They're going to automatically do it just because the distances are going to be dictating.
Okay, so I guess it's very doable then in a simulation, just to have like the force bits kind of doing this kind of thing.
And exactly. I
guess I'm more confident now that it's going to work, basically.
Yeah, you can just randomize. Like I said, that's what's actually physically happening. So I'm just saying you can just randomize the exit of the bits of energy, and where they are in space can be randomized, and it's just inevitable that you'll end up, like I said, there's only these vectors are the only possible vectors that could arrive here at the same time and be a full wavelength out of phase. But the point is that you have to keep sending them, because obviously this one will come in a second later. I'm saying part of the out of phase is that these two occurrences, the two events that are going to combine, are not going to happen at the same time. One photon will scatter here and go this shorter distance, or let's say a longer distance, and the other one will go a shorter distance, but he showed up 2 seconds later. So even though this bit's going to be the first bit, and it went the longer distance, this bit's going to be the second bit, and it's going to be the right time delayed because it showed up later.
Okay, I think I kind of get it, but I feel like I'd probably be.
Yeah, I mean, you're having to
Surprised.
reconstruct something again. Like I said, it all depends on what you think a photon is. I'm saying a photon has to be a composite object. It has to be made out of more than one thing, and so obviously it has to happen over a period of time.
Yeah, so I would need the simulation to pick up like the photons at like these ends, right? Um, so to pick up a photon would just mean that if there's like a certain, like you have to kind of time the amount of time it takes between each force bit that hits you, right? And if it's like the same amount of time, then you're kind of like in phase.
Well, look, they just do the simple math. I'm just saying it depends on whether you want to do it right, like completely right, or whether you want to do it so it just looks like their math. I'm just saying their math doesn't worry about any of that because it just says they're either in phase or out of phase, and it doesn't worry about sequential or not. Okay, it's not rebuilding a composite object. They're not trying to rebuild waves. Okay, they're just saying it either is in phase or isn't in phase, and they don't care about waves. They don't care about how many nodes there are to the photon. So their mathematics is much simpler in the sense that it just says, are they in phase or out of phase? Do they arrive in one of these allowed moments in time, 500 nanometers of time, right? Whatever, at the speed of light, right? If you have 500 nanometer light, you're just saying how much time does it take for a bit to move 500 nanometers at the speed of light. And so you're basically just saying that if it's an interchrome, if it's 500 nanometers of difference in time at the speed of light, then they're in phase, and you say that's a place that gets light. So I'm just saying their math is already cheating in the sense that it's not worrying about the fact that they're timed events and that some of the events are happening because of photons arriving later and earlier at the two slits.
So I guess anything like this would be kind of like not a good photon, or like it would.
Yeah, well, it can't be a
photon,
photon, right? I mean, a photon has to be a consistent frequency, or the electron that it's going to interact with won't know it's a photon.
Yeah, I think the common argument that, like, academic physicists give is like some kind of, they just kind of draw you a picture like that, and they're like, oh, this is what light looks like. It's just a wave, and what's happening is that there's another wave that's canceling it out.
Well, we know it has to be at least two. We know it has to be at least two nodes to have the frequency. So you can't make a frequency without having two. So you know that to have I can't make this. If I draw that, no one's going to know that's a frequency, right? I can draw one wave on the ocean, and that's not going to tell people how often the waves come to the shore. There's no frequency. I have to draw the second wave. So I have to have at least two waves before I have a frequency. You can't see the distance of the waves without it, realistically.
Yeah, they do something where they just kind of say it's a sine wave.
I understand, but they draw this. They don't draw one wave and say that's a photon. They draw a whole bunch of waves and say that's a photon.
Yeah, and I don't really buy into this canceling out thing where like these two would cancel each other out or something, or
well, they're two different fields. That's all. That gets into the whole Maxwell crap. So that's not really the two-slit experiment, but I mean, that's their theory of light, that they think it's made out of some sort of fields that are both, stretched or compressed or some other kind of garbage. I mean, there's no description of what that wave represents, whether it represents a compression of ether or an expansion of ether or what it represents. There's nothing. And the fact is it's polarized, so we know spatially that polarization is spatial. So polarization takes up space. It's a size, and they don't put that in their wave at all.
Yeah, I think that they're just kind of like trying to fit in a bunch of holes that they can't really fill in.
Well, I'm just saying, wave theory is essentially dead when I just drew this, okay? When I drew the single slit and I told you this is mathematically where the point sources are, here at the surfaces. Now, if I draw waves like that, you'd say that doesn't make any sense. If I had waves coming in, the waves went half over the surface and then broke here in the middle for no reason, you'd say that doesn't make any sense. Why did the waves break in the middle? And why are they going over the surface? That doesn't make any sense. Waves aren't going to do that. it's not the right place in the point sources. A wave has to do this. This is what it does in water. This is what it does in sound. Water and sound just do this. They don't create two waves that interfere with each other. So I'm saying that obviously wave theory is nonsense. It doesn't work. Plainly.
Yeah, I think it's.
And especially in the
Yeah, it
double
doesn't work
slit,
at all, and
it's kind of obvious in the double
particle theory
slit,
just kind
in,
of works.
in the sense that the double slit, they say it's two waves. Well, two waves won't get you the right sizes because this distance will be wrong. The distance that works in the math is the distance between of the impediment is creating the envelope pattern, and the two outside surfaces are creating the vectors that'll give you the size of the bars. So the number of wavelengths in this furthest distance, that's the n number of wavelengths in that distance is going to tell you how big these bars are.
Okay, I guess we should talk about the double slit then a bit more, just because I'm not 100% about why the envelope pattern is there, like the.
Well, it's there because there's two sources. So you have four sources altogether. So the single slit, as I just pointed out, is the two source experiment, right? It's two surfaces. So there's two sources. The double slit is the four source experiment. So there's four sources, right? Each surface is a source. And the point is that the interior points, this distance is obviously smaller than this distance, okay, between the outside ones. This smaller distance is essentially the single slit experiment in reverse. This distance would be the same as the slit opening in the single slit, or it would be the size of, say, a needle. So it's doing exactly what it would do.
See what you're saying.
If it was a needle, it would do this. It would create these big bars, okay, and that would be the pattern because it's a small distance. Say there's only 5 wavelengths here, who knows? There's 10. There's 10 wavelengths. It's going to make big bars, and this distance is going to be, say, hundreds of nanometers. I mean, hundreds of wavelengths. And so that would be making little bars. And the point is that the amount of light is smaller because there's this big impediment right here in the middle blocking all the light. So there's less photons going through. And the fact is you can't see either one of these patterns without each other. So only where both of them line up do you get a bright light. So all 4 sources have to be in phase. All 4 sources have to be in phase to have light. And where 2 of the sources, say these 2 are out of phase here. These 2 are out of phase here. The big bar, no light. And the little ones are in phase though. This one and this one are in phase, but there's not enough light, so you don't see anything. So all 4 sources have to be in phase. That's where you see the light, where all 4 sources are in phase. So all you see is the little bars. You don't see the envelope pattern. You just see it as a pattern in the sense that you see these empty spots where the envelope is making itself visible because there's not 4 sources now. There's only 2 sources that are in phase. And there has to be 4 sources in phase to have enough photons to see them.
Okay, that's pretty good, I guess, as an explanation. I think the really good explanation you gave was just when you were showing with the single slit experiment. Just doing this kind of helped me a lot when you were showing, like when you move the string, if it's a string.
Yeah, well, the single string thing I think makes it kind of obvious that the pattern is limited and there can only be so much of it. There's no infinite pattern. There's no infinite planes.
Yeah, that's what was bothering me. I kept thinking, like, if it's random, then maybe the phase should be in and out of phase like a trillion times or something.
Yeah, well, yes, there aren't enough geometric locations in space. There's all this is just 90 degrees, so it's just 1/2 pi is all you're working with here in terms of this length of this line. So all you have to do is multiply this line, the radius, all right, to some fixed point. It doesn't matter where. You could do this as the radius. So you just measure that distance, and you just say, well, I want to know what the arc is at some at some distance. And I'm just saying all you do is multiply it by 1/2 pi. So all you do is take 1/2 pi, multiply it times r. So 1/2 pi multiplied by r, and that the distance you're saying how far out you want to go, and that'll tell you exactly, that'll tell you how much longer this line is than this line, and that'll tell you how big the wavelength notches will be. That'll tell you how big these bars of light will be. So yeah, when you put it on a flat plane, you just distort it all. You won't get any correct mathematics, because this bar is going to end up being infinitely big. This bar here will end up being infinitely long in the end.
I guess that was kind of confusing to me, but I guess we should probably just move on.
Well, I just mean that if you project something on a flat screen, everything distorts. So if the thing that's on the edges gets fatter and fatter and fatter. So the middle of the screen looks just fine. So if I had a very wide screen and I'm projecting something on it, everything in this section will be fine. It gets fatter here, everything gets wider, and it gets wider out here and wider out here. And I'm just saying eventually that wideness is infinite.
Yeah. So that's why you have to do the curve, right?
Well, I'm just saying it happens in space on a curve. It travels through space equidistant. If I said where are the photons 1 second later, the photons are going to be here, here, and here. You know what I mean? They're not going to be on a wall somewhere. This is a much longer distance, to get over here. They're not going to get on a flat screen at the same time, because some of them have to travel a lot longer distance. So obviously they can't get to the screen at the same time. If you want to know where they are in space at any 1 second, it's always going to be on a curved line.
Yeah, that makes sense. I think the actual experiment usually they do it on a surface that's not curved.
Yeah, well,
right?
that's the whole problem, is they're viewing it on a not curved screen and then claiming their mathematics is 100% accurate, and it can't be because everything got fat. Everything is getting way distorted. So as soon as they go a little bit out, they're going to start getting wacky numbers because the pattern is being distorted. All these bars are exactly the same size in space. In space, they're all the same size. No matter where I go, and I go equidistant, they're all going to be the same size.
I guess the actual picture doesn't look too distorted at the end, but I guess I should just look at it again.
I don't know what you're talking about, but okay. I'm just saying, if you take an old video and you look at it in a widescreen mode, you'll see that everything gets stretched on the outside. The further out you go, the more it stretches.
Okay, I just Googled it and I saw that, so forget what I just said, basically. Yeah, I'm not too sure what else to talk about since we went over the double slit and single slit.
Yeah, well, it's okay. One subject is kind of good. I'm just trying to think of some other points that somebody else made that I wanted to reference. I'm just saying that their math is already a concession to the whole argument. And so there really just isn't anything other than these vectors from point sources. All the math has in it is these distances. This is all that's relevant. This distance, the distance between the points is the only thing in the math. That's all it is. That's all the experiment is. So the single slit looks just like this, mathematically is the same as the single impediment, because all you have in the math, so if I make a single slit that's the same size as an impediment, the math is going to give you exactly the same answer for the pattern because the distance is exactly the same. So there's no distinction of whether the slits or the surfaces are facing in or out. The point is that they're just point sources. They're just places where you're going to draw two lines to a location. And you're just going to say, where are those two lines, one wavelength? One of them is one wavelength longer than the other. And everywhere where one of them is one wavelength longer than the other, or two wavelengths or three wavelengths, one full wavelength of units longer, a whole number of wavelengths longer, then those are all going to be locations where you're going to have a bright spot. And that'll tell you exactly where they are. And again, the double slit just says there's 4 point sources, and you can kind of just figure out that the one distance is really small. It means a small number of bars. One distance is really big. It means a lot of wavelengths fit in there. It means a lot of bars.
I think that makes perfect sense to me, and like they don't really explain the envelope pattern. I think I remember seeing a video where Professor Lewin was kind of just glancing over it or something.
Well, he didn't even pay attention to it at all, right? He didn't even acknowledge its existence. So, and most of them don't. They just say the double slit pattern is a bunch of bars of light. They never talk about the fact that, oh yeah, there's no light, and then it turns back on again, and then there's no light, and it turns back on again. They don't talk about that reality. So, because they don't have an explanation, they have no way to draw it. Because again, to draw it would be to put waves in these ludicrous positions. This is where the waves would have to be. You'd have to put the waves would have to break in the middle of the opening for no reason, and then two of the waves would have to break right in the middle of the impediment, which would be insane. So there's no way wave theory works.
Yeah, it's hard, like trying to make it work just kind of is annoying, I guess.
Well, I'm just saying I could make this work. I could make four waves, and I could make it work mathematically with the four waves. But I just say you can't make it mechanically work, in that no wave would ever do that. Sound doesn't do it. Water doesn't do it. No waves do that. Waves don't.
I could kind of tell that they were up to something kind of fishy when they were doing this thing, like two waves going like that.
Well, exactly, and those mathematically don't work. That's the irony, right? So when they do that, they're giving up on the math, because you can see clearly, when they do these two waves inside here, Huygens breaks it here, you can see that clearly now your point sources are here and here. So now you have to use this as the distance. And that distance won't work. This is the distance that works. This is the vectors that will get you the right answer. These vectors will not get you the right answer. They're the wrong bar size. There's too few wavelengths between these 2 points. So where the wave centers would be in the middle here, that's too small a distance. Your blocks are going to be smaller than that because the real surfaces are out here in this bigger distance. So they can't mathematically make sense. They can't do it mathematically. They can't put them there mathematically and get the right answer.
I mean, the fact that they broke it in the middle is kind of just like you're just gonna do stuff like that without explaining it. Like that would only make sense if it was the double slit experiment and there was actually like a piece of matter here, like something.
Well, exactly. Well, I'm just saying it doesn't work mathematically and it doesn't work mechanically, because there's no explanation for why the wave would break here in the middle of the slit. Why would a wave break there?
Yeah, they're just claiming that, basically.
Well, they're trying to make it into a wave drawing, and it doesn't work. Okay, so they're forcing it, and the force is breaking the math. So if they put the waves where the math works, like I said, that doesn't look right either. This doesn't look right either. Okay, I mean the wave breaking in the middle and then going over the sides of the surface doesn't make any sense either.
Yeah. I don't think waves are a good explanation for light at all.
Well, it doesn't explain the point source stuff. Like I said, this is not a single slit experiment. This is not about a wave going through a slit. This is about two surfaces. And the double slit is about four surfaces. That's what proves it's not about waves.
Yeah, I feel like I gained a lot of knowledge just from talking to you about it. I guess.
Good.
It's kind of weird because I feel like you explained it all just the same way in the previous videos, and just somehow I just learned it.
Yeah, well, I'm on the wrong side because obviously I already know it, and so it all seems like it all fits for me, and I'm not appreciating that somebody else is, I'm explaining a platypus to somebody who's, never been to Australia or whatever, and they're like, oh, come on, you gotta be kidding.
Yeah, it's pretty classic, for people, if they're teaching someone math or something that's much lower level than what they already know, they'll just kind of think it's really easy and just speed through it or something.
Yeah, I have to have some way of just emphasizing how simple this is. This is really, like I said, their own formulas really are just dealing with vectors. It's just two lines, and all you're really saying is where are the notches on those lines? What are the number of wavelengths that fit into those two lines? And that's telling you the answer. If there's not an even number for one of these lines, then there's no photon. If you can put the wavelength into this total line and it comes out even, then you know it's in phase. So it really is just
Yeah.
about getting odd or even number. Getting whole or fractional answers. If you get a fractional answer for the length of the line, it's not going to be in phase. If you get a whole number for the length of the line, it's in phase. There's going to be light there. It's that simple.
Yep, that makes sense to me. I think like your model is pretty much the best I've come across, and one of the things probably that is most impressive about it is just like you can simulate all the different properties and all the different effects, or at least it seems
Well,
like
I'm
you
just
can
saying you can
simulate
do it
everything.
all with two forces, two bits of matter, and two interactions. The fact that you can answer all these questions with just such elemental bits, and again, even the gravity equation is so simple by just understanding momentum is used to move matter, and that little bit of momentum being used means there's an absence of an equilibrium problem, and that the Earth actually does absorb more energy than it actually excretes, and so that's why there's gravity.
Yeah, and it's all doable to like imagine, and you can imagine different pieces and stuff. Usually, that's one thing about your explanations is like it's all kind of there. There's nothing really that feels like it's missing. Whereas if I hear their explanation, I'm kind of like still in the dark pretty much.
Well, there's
What
still
that means.
little pieces missing, but I'm just mean these are tiny pieces missing versus their glaring, gigantic, like they're just no explanation. Bent space, what is it? What does that even mean? How do you bend space in 3 dimensions? It doesn't make any sense. It has to be a convergence. How can every little particle in the universe be a vacuum cleaner? Where does all the dust go that the vacuum cleaner sucked? I mean, there's all these open questions for which there's just no answers.
I mean, I guess like they don't have the answers, so they have to find something to talk about. And I guess like it might be better for them to talk about all these like wave theories and positrons or random particles that
Well, yeah, I
don't
don't even want
exist.
to get into all the stuff they made up that only lasts a trillionth of a second and that doesn't have any role to play. They have a model of the atom where they have a bunch of stuff going on for which is completely superfluous. When they know the only thing that really happens is the charge phenomenon between electrons and protons. That's the only
Yeah, they
stuff.
have this really weird
That
like,
controls all the chemistry. That controls all the atomic bonding. What do we need positrons for? They serve no purpose whatsoever.
and the worst part is like they'll say that the electrons are spinning one way, and then they're also spinning the other way at the same time, and
Well, and
somehow
that
like
they're dipoles. How can there be a dipole and also be negatively charged? It doesn't make any sense. How can there be magnets and charges? You can't be both. Not
yeah,
possible.
and like the whole idea of just electron spins two ways at the same time, like it's
Well, I
just
don't know
like
if they're saying
a
it's spinning
5-year-old should be
two
able to
ways
say
at the
that's
same
possible.
time, but they're saying it spins, and that's in itself is, based on no evidence. That's based on watching ions. Ions aren't electrons. I mean, ions are lopsided atoms. Of course, ions could spin, but electrons
I mean, if
don't.
they just said it was just spinning, I would be maybe a bit more okay with it. But they're saying it's spinning in like two directions, and I don't know. I think they're saying it cancels out or something.
Well, I don't think they're saying it spins in two directions. They're saying it's a dipole. When you spin a dipole, that means you're showing the north side of the magnet as much as you're showing the south side of the magnet. So if you spin an electron fast enough, you can't tell whether it's north or south. You get it? I mean, if I spin a
Sort of,
magnet,
but
if I spin a magnet, you can't tell whether it's north, south side, right? If it's because half the time it's south, half the time it's north. It's
yeah, but I've
saying,
seen like memes where they just kind of outright say like this is how it works. It's spinning. It's like one half spinning plus and one half
well,
spinning
I know, but
minus.
most of the time they admit they don't even mean it's really literally spinning. They just mean spin is a quality that it has, a property, and they're not even saying it's actually spinning. So, it doesn't make much sense at all. When you get the deeper you get into it, the more convoluted the language gets. Words like spin don't really mean anything. They don't really mean it spins.
Yeah, like the simple words become not what they're supposed to be, and then they add a bunch of more complicated stuff that probably just confuses
Yeah, I
people who
mean,
don't.
wave is a verb. It's not a noun. I mean, these are just things you got to know. I mean, there's no such thing as a noun wave.
Yeah,
It's always
like,
waving, and it has to be waving in something. And they're just evading all of that too.
yeah. I don't know how long it'll take for it to become more well known that there's another theory available.
Yeah, well, it's not even just that there's another theory. The one that exists now, people should be they should be really angry that they've been manipulated and they've been lied to and they've been given a very distorted view of the evidence. I mean, the video I just played where Dr. Becky is sitting there saying that Young did electron experiments when nobody did electron experiments for 100 years. It took 100 years from Young's time to do electron experiments. I mean, she's so far off. And then the whole idea of electron two-slit experiment, like I pointed out, is completely theoretically nonsense. You can't even do the stupid thing. It never would be a two-slit experiment. So, I mean, they're cheating vocabulary so egregiously. I mean, to say they've done experiments they have not done, it's just a fact. It's a fact. They have not done an electron two-slit experiment. They haven't done it.
Yeah, I think they claim that it does some weird thing where I don't even know if they claim it's doing the same thing as the single slit experiment with light.
Well, that's what they're claiming. It's making the same pattern, but they're claiming it's a slit experiment. It's not. I'm just saying you can't shoot electrons through slits. It's just too stupid. You can't make small slits for electrons. Electrons, the slits are going to look like, the Pacific Ocean. It's going to look huge. You can't make a confinement for an electron. It's impossible. They're tiny objects.
Yeah, I don't think you could shoot them out of a gun. I think you were saying that you can't shoot electrons out of a gun?
Well, you can, but you're going to shoot it with a bunch of other shit, too. The electron gun is made by just heating an element and then creating a charge for the hot stuff to jump across. So you're releasing little charged bits. So when you heat something, you ionize it. That means you make ions. That means you freed some electrons. Some atoms have too many. Some atoms have too few. So you've made a bunch of lopsided stuff. And it's hot, and so it's jiggling around the surface, and then you just put it in a charge field, and then obviously the electrons will head for the positive and the protons will head for the negative. So you're just basically giving the electrons some reason. Now they've been liberated, you're giving them a reason to move. But what's really moving them is the fact that when you did all of this breaking stuff, you released a whole bunch of X-rays and gamma rays. So when you want to make a gamma ray gun, you make it exactly the same way as you make an electron gun. And if you want to make a proton gun, you make it exactly the same way and you just change the polarity. You just reverse the polarity of your electric charge. So these guns are all the same. The proton gun, same as the electron gun, same as the gamma ray gun, same as the X-ray gun. They're all the same guns.
I guess that makes sense. I don't know too much about their guns.
Well, I just mean it's all the same principle you're using. You're just heating a piece of metal, shooting pieces of it off by having it very hot, and then just creating a charged field for the pieces to fly through. So it's always the same gun. It's made exactly the same way.
Okay, that makes sense.
So it's a junk gun. It's never an electron gun. It's a gun that's shooting a lot of crap. It's a lot of junk comes out of the gun.
And I think they use it to say that there's an observer, like the observer being there and observing the experiment.
Well, that's old rhetoric, but that goes back to, what the original people who made this crap up actually believed and now what they believe. And the word observation is just another word for measurement, and that's just another word for interaction. So they're all the same thing. If I'm going to observe you, I could throw electrons at you. I could cover you with silver, and I could throw electrons at you and watch them bounce off the silver. You know what I'm saying? I could know where you are because I see an image of you out of the reflected electrons. I could throw bowling balls at you, and some of them would come back, and that would tell me, well, there was somebody there because the bowling balls, some of them bounced back. So it's always interactions that tell us that something exists. So that's sort of a measurement. Every time you have an interaction, you've measured something. But the fact is that everything is constantly interacting, so it's constantly being measured and it's constantly being seen, even if nobody's watching the camera. So I have the camera on, I'm not looking at the camera. Does that mean the camera's not on and the camera doesn't have an image? Of course it does. Whether I look or not doesn't matter. The camera's on, it's collecting photons.
Yeah, that's the conclusion they were coming to from the electron double slit experiment. I think I remember reading that a while ago.
Well, regardless of where they got it from, I mean, they got it through the whole argument with Bohr and Einstein. But regardless, it's a silly argument that any of this is under any doubt about where things positions are, and um, that everything is constantly being. Schrodinger's cat never has a privacy. Gamma rays are watching the cat, right? They're going through the box, hitting the cat, hitting everything. So everything is always being watched. So there's no observer that never is not looking. There's always something looking because you're always interacting with forces. I mean, the cell phone, your Wi-Fi, it's all looking at you right now, okay? It's looking at you. Now, nobody's interpreting the reflections, nobody's interpreting the data to see you, but it doesn't matter. The photons are hitting you, the energy's hitting you all the time.
Yeah, so your phone could be seeing you by like just noticing or something that you're blocking a lot of the light that's coming through.
Well,
or
yeah,
something?
exactly. I'm blocking radiation, and I'm reflecting radiation. So in different directions, I'm always visible if you have the right detector, right? So if you just turn on the right detector, you could detect me. So the fact that you're not looking doesn't mean I'm not being detected.
I guess, but then it's like kind of weird because you have to talk about a human observing it and scientifically or something and
No, well, I mean, but I'm just saying there's no, whether I look at the camera or not would be idiotic to say that would make a difference, right? So it has nothing to do with the human looking at the camera. It has to do with whether the photons are going in the camera or not. If the photons are going in the camera, the person's being viewed.
Yeah. So I don't know how they came up with that because I think it was a while ago that I read about this.
Well, I'm just saying it's old stuff. It's back in the 30s. So it's obviously just the Einstein problem. That Einstein didn't go for this woo-averse, and that's where they invented all this wooey crap that somehow everything doesn't have a position in space, and everything doesn't know where it is, and everything is a piece of mush, and it's in 17 different places at once, and it's doing all these different things, and that's where all that started. And for some reason, most physicists gravitated to that silly story.
Yeah, it's hard to know why they gravitated towards like kind of silliness. I mean,
well, I think it's because they weren't. They're academics. They were nerds who lived in a little fantasy world. I don't think they ever built anything or actually did anything. These weren't mechanical people. These weren't these theoretician types. These weren't the people, the hands-on people, the people gluing shit together and building shit. And so that's why they did it. It's because they didn't live in reality.
Yeah, and especially if you read like Sean Carroll's stuff, he pretty much just made up a whole DC Comics universe and like.
Well,
sure,
I don't know if he
guess.
made it up. I mean, he's obviously just telling the story as he heard it and as he believes it. So he obviously has bought into this silly religion that there's a new universe created. Because all of your mathematical errors disappear if you can just create new universes for them all to take place. And so it's easy. It cleans house. So I mean, multiverse is just like dark matter. It's just a God of the gaps answer. So instead of answering the question, you just evade it by creating a special condition that has no loopholes.
Yeah, I don't see how like he can study physics for so long and just still think that's a good answer or like a reasonable answer or something worth writing a book about.
Yeah, well, to think it's being scientific when we really shouldn't be that desperate. I mean, there is a lot of evidence here, and we really shouldn't be so desperate that we have to go to dark matter and multiverses. Those are desperately silly answers.
Yeah, I think on string theory was one of them.
Oh, well, that's also just, I don't want to get into string theory because it's just math. But it just basically it's basically saying, look, we know there's yin and yang in the universe. We know it's a tug of war between particles. So obviously, the simple answer is just make everything out of rubber bands, because now you have your yin and your yang, right? You don't have to figure out how it mechanically happens anymore. You can just blame the rubber bands, and that's all string theory was. It turned all the forces into conservational yin yang.
Yeah, it's not even worth like my time to just even like look into it and try to see what they're talking about because.
Well, I'm just saying you have to be doing third year college math to even start, because it's really not a mechanical form. It's not a mechanical drawable model. It's just a mathematical model.
Yeah, I'd have to be in school to do that.
Yeah. Well, you have to be in school and having some sort of psychotic moment to think there's any point in doing a bunch of abstract math that has nothing to do with reality.
I mean, you could maybe some people enjoy doing math or something, and they
Well, I understand regular math, though. I could understand. I took probability in high school, and I enjoyed it. And statistics. So that's sort of interesting math, figuring out all these permutations and stuff like that. But when you're doing all this abstract crap, where you're actually creating non-real numbers and all kinds of abstract matrices and all this other crap in fourth dimensions, well, then you're just gone. You've left the building.
yeah. I guess it could be useful like matrices for computers and stuff, but um,
Well, I'm just saying they're
it's
not
really a
useful,
math
in
thing.
my opinion, when they're violating the fundamental rules of what a dimension is supposed to be. So, yeah, if you kept them in three dimensions, I wouldn't mind. But, when you break the rules of dimension and then use the same word and say, I'm just going to create a fourth dimension, and it violates all the rules of a dimension. It's not at right angles to the other three. It's not any of the things it's supposed to be.
Yeah, I think I was taught with four dimensions when I was taking like a modern physics class.
It's just a waste of words because, again, it's breaking language. The dimension has a strict definition. The three dimensions all conform to a rule. And there's just no room for a fourth dimension that obeys the rule. The rule is you have to be 90 degrees to all the other three dimensions. And if you're not 90 degrees to the other three dimensions, you can't be a dimension. So the fourth dimension can't be a dimension because it can't locate itself at 90-degree angles to the other three dimensions.
Yeah, and they still include it in the like matrix or whatever as like
Well, I'm
the
just
next
saying
dimension or something.
you can always go X, Y, Z and then do your stupid Z line. You can draw it, but it won't be rational. It won't be 90 degrees. It won't be obeying any of the rules.
Yeah, it's just like extra complicated math that might confuse people, I guess,
Well,
if
like I
they're
say, it's
not
not
like
just
understood.
complicated. It's abstract. It's not connected by rules. So I'm just saying it's irrational math.
Yeah,
It's not
I guess I haven't done
obeying.
that much of it
It's
to
not
know exactly
obeying.
what the meaning by
Rules are
abstract
sort
stuff.
of important, and it's not obeying them. So, but anyway,
Yeah, I guess
all
it
right.
was a nice conversation.
Yeah, good enough. So I appreciate your interest. Appreciate the sincere effort to understand, and we'll do it again, and such. And I'll
All right, sounds
try to
good.
record it with a better system than this. But anyway, till the next time, and such, and so forth and whatnot.